All right, guys, here we go with something called degree and radian measurement. Um, Hopefully you've seen this already, and it's just going to be a little bit of a review. But if not, I'm going to assume you don't know it. So let's start out with something you're going to see a whole lot of, which is called the unit circle. So I'm going to try my best to draw a circle. What? Okay, well, kinda. Anyway, we start over here. This would be called 0 degrees. If I were to start at the origin and draw a 0 degree angle, well, I'd end up on the x-axis. Now, as I rotate in a counterclockwise way, I can generate different angle measurements. Now, you guys would know that any angle I could draw starting at the origin and traveling this direction, as long as I stay in quadrant 1, I would be generating acute angles. So just looking at the angle I just drew, a good estimate of how big that angle would probably be about 40 degrees, let's say. Maybe 41 degrees, I don't know. But you get my idea. Hopefully from geometry you remember that stuff. But there's more to it. We don't just stay in quadrant 1 anymore. We will be drawing angles all over the coordinate system. So I'm going to get rid of that drawing I just made. And I'm going to say, well, so we start at 0 degrees. And if we're going in a counterclockwise direction, the way my arrow is there, we call this positive rotation, or we call these positive angles. So all the way up at the top here, that would be a 90-degree angle. I would form a 90-degree angle because when we make our measurements, we always start right here on the positive side of the x-axis when we are writing degree measurements. So we get a 90-degree angle there. I'm going to get rid of that little 90-degree symbol because, whoops, come on, get rid of it. There we go. And go all the way half circle. Well, we all know that's pulling a 180, right? If I went all the way over there, we also call that a straight angle because it looks like a straight line if you start at 0. And then I'm hoping you go, oh, that's 270. This is coming back to me. And if I make a full rotation, all the way around, I would be all the way back to 360 degrees. So, let me ask you just a question. If I asked you to draw a 120-degree angle, or just visualize what would that angle look like, which quadrant would I end up in? Remember, I have 4 quadrants. Would I be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? And hopefully you say that's easy. I would end up in quadrant 2. You'd be correct. But what if I take that same angle and I stick a negative in front of it and I say, where is a negative 100-degree angle going to end up? Well, when it comes to this stuff, well, I'm going to be traveling in this direction. When we talk about angle measurements, oh gosh, I tried to squeeze that in there. That says negative. Oh my God, that's kind of ugly. That would be negative rotation. Negative rotation is clockwise. I really hope you can see what that says. That says the word negative. But we have negative rotation. So instead, we would say, okay, I start at 0. I always start on the positive side of the x-axis. But if I did a negative rotation, let's say, well, I would say that's negative 90 degrees where I just stopped. And then I'd go a little bit more, 30 degrees more. And I would end up like right there. So you could say this is a negative 120-degree angle. And I'm hoping that this is not new stuff to you. I'm also going to remove that, get it out of the way for a second here. But what we do in trigonometry is a lot of the time we do not measure things in degrees. Most of the time we will use radian measurement. Now, it doesn't mean I hate degrees. I have nothing against them. But we have a different world. So over here, this is like my description of what it looks like when you're talking about degrees. But over here, I'm going to draw myself another unit circle. And here we go. Let's see. Oh gosh, oh my God. You know what? I can do better than that. Give me one more try. That was really bad. Okay. Not much better, but okay, you get the idea. See, here's the difference. What I'm going to illustrate over here is something called radian measure. Now, we call it a unit circle based on this. The circumference of a circle is 2 pi r. And no matter how big the radius is, when I go around a circle, it's still 360 degrees, no matter how big that radius is, short radius, large radius. If I travel around the outside, it's 360 degrees. So what they do is they say, well, what if the radius was equal to, let's use the easiest number in the world we can, what if that radius was 1? Well, then what would the circumference of that circle be? It would be 2 pi. And what does circumference mean? It means distance around the outside. So in Radian Town, we don't call this 0 degrees, we call it 0 radians. And if I go all the way around the outside, I call it going 2 pi radians. Whoops, what the heck did I just do? Whoop, no, that's not it. Oh boy, there it is, thank you. So 2 pi radians would be 1 complete revolution. So when we talk about measuring angles, we can either do it in degrees or radians. Now, let's think about it then. If we start at 0 and we go halfway around a circle, well, halfway around would just be 1 pi, not 2 pi. And then we have some little fragmented spots in between. Halfway around would be pi over 2. Half of pi. And then if I go a little bit farther, this guy is 3 pi halves, okay? 3 pi halves. So what I'm trying to get at is there's different ways you can classify angles. One of them is using the word degrees. One is using the word radians. And believe it or not, you will eventually get extremely good with radians. See, I am damaged. I have this, I look at, like somebody says, what is a 3 pi fourths angle? And I instantly know the answer is 135 degrees. I'm just ruined that way. It will happen to you also. It will. But in the meantime, I just want you to know, we can have positive rotation with our radian measurements. We can also have, and I'm not even going to try it this time, I'll just write it sideways here, negative rotation with this. So if I asked you, can you draw me a 3 pi fourths angle? And you might say, God, 3 pi fourths? That's a weird sounding angle measurement. Yeah, but think about it. It would put me in which quadrant? Because once again, we don't change the names of the stuff we've already determined. These are still called my 4 quadrants. We still use Roman numerals to describe them. We still start every angle measurement from right here going either positive rotation or negative. So 3/4 is halfway between pi over 2 and pi. So if I asked you, could you sketch this angle? You go, okay, I end up right there. This would be a 3 pi fourths angle. Now, all I want to get out today is this concept that there's 2 different ways we can measure an angle. That's all I really want to accomplish with this lesson. So, I'm going to erase that so there's not a lot of junk in the way. But, come on, get out of the way. Okay, that's all gone. So, if 360 degrees is the same thing as 2 pi when it comes to radian, there's got to be a way so we can convert this kind of stuff. And it just so happens that there definitely is a formula for this stuff. It goes like this. If I take any degree measurement, so like 45 degrees, if I multiply it by pi over 180, I will convert it into radian measurement. Well, this is just a fraction times a fraction. I can cross cancel if I want. 45 goes into itself once. 45 goes into this 4 times. So I can convert into a pi over 4 angle. If I take any degree measurement and I multiply it by pi over 180, I can convert it into a radian degree measurement. So I go, oh, once again, whoops, I should have wrote a degree symbol. I could say cross cancel. 60 goes into itself once, 60 goes into that 3 times. The answer is a pi over 3 angle. Now, this hopefully was something you saw in geometry, but if you forgot about it, it's coming back. Also, I still have my buddy up here, negative 120. My buddy right here, negative 120. If I wanted to take something like that and convert it, I still just take pi over 180. I multiply, but this time it doesn't go in evenly. Like 120 does not go into 180, but 60 does. 60 goes into that twice, but remember it's a negative number, so negative twice. And then 60 goes into that thrice. So my answer is negative 2 pice over thrice. So, what are we going to be doing in this very first lesson? We're going to be converting stuff. Now, you might want to grab your calculator because some of these are not as easy as others. For example, they might say something like this, a negative 600 degree angle. Please convert that into radians. To convert to radians, I go pi over 180, I multiply it. That's the formula. That's how we do it. And then I look at that and I go, wait a minute, this time, negative 600, how do you have a negative 600 degree angle? That's crazy talk. No. For those of you guys who are snowboarders or whatever, you could go around the circle 360 degrees. You could in a negative direction. I'm going in a negative direction. And then I could say, well, that guy right there is not 600 degrees. But if I do 600, take away 360 because I've already traveled that far, I'd just go 240 degree more, and I'd get there. Now, did I go 240 degrees more than that? I don't know. So let's see here. That would be 90. That would be 180. And then, yeah, a little bit more. That would put me right about there in downtown quadrant 2, right? So that complete rotation is called a negative 600 degree angle. But if I wanted to convert that into radians, well, I'm looking at it. I think the best way to do this is divide both by 60. I think 60 goes into that 10 times, but it'd be a negative 10. 60 goes into that 3 times, so I end up with a negative 10 pi thirds angle. And this would be called the radian equivalent of that thing. So far, we okay? I hope so. If not, then this is when you ask yourself, do I have questions? Because if I do, I can ask them in the Zoom room when I'm done watching this video. But really, all I want to accomplish in this one little lesson is how to convert from degree to radian and radian to degree. And it comes from this relationship here. It really does. Think about it. 360 Look, huh? That would cancel. I'd get 180 over pi. Well, guess what? If you multiply that times any radian, you will convert that number into degrees. And vice versa. If you look at the relationship the way I've been using it, it's this way. Those are our two conversion formulas. If I take 180 degrees divided by pi times a radian measurement, the answer will be in degrees. If I take pi divided by 180, which I've done already, times the degree, it becomes a radian. So if you're going from one to the other or the other back, the formulas are very similar. One of them is going to allow you to cancel out the degrees and be left with a statement that has pi in it. So check this out. Look, I started with 45 degrees. I ended up with pi over 4. Started with 60, I got pi over 3. Negative 120, I got a negative measurement, but it had pi in it. And down here, same thing. So let's go the other way. What if they say unto me, what if they say, I have a 5 pi fourths angle, and I would like you to convert it into degrees for me. See, I look at this thing and I go, okay, 5 pi fourths. And you don't have to draw the picture to really do it. But in radians, I start here and I'd go, okay, that's pi over 2, that's pi. But you know what pi is? It's also 4 pi fourths. So like right about there, that would be a 5 pi fourths angle. That's what it would be. Well, what does that look like in degrees? I multiply by 180 over pi. That's how I convert. Because what happens then? The pi will always cancel the pi. Then I could say, hey, 4 goes into 180, and you either have it like, you know, you grab your calculator, it goes in 45 times, but if you have to, you go 4 goes into 180 45 times. But see, I'm going into degree mode now, so I start adding this little tiny symbol, and then I go, hey, what's left over? 5 times 45, and I go 5 times 45, the answer is 225 degrees. Now, I mentioned the picture here. I drew the picture because I don't even think about it anymore. I know where radian measurement, I'm so used to seeing it, I don't think about it anymore. But you guys, your brains have been trained up to this point in your life to understand degrees. So if I said draw a 225 degree angle, you'd probably go, yeah, I'm going to end up in quadrant 3, I get it. But if I say a 5 pi fourths angle, you might not feel as strongly about your convictions. So when they give you something like this, I want you to draw a 3 pi fifths angle. Now let's get a little funky. And I want you to convert that thing into degrees. Well, me personally, I know that if I were to draw just a quick little sketch here, boom, that 3 pi fifths must be, what, in here somewhere? Is it here somewhere? Is it quadrant 1? Is it quadrant 2? Well, let's figure it out. I'm going to take 180 over pi. Let's figure it out for sure. Never guess when you can actually find out the answer to something. I cancel the pi's, and then I go, you know what? 5 goes into 180 evenly. It does. It goes in 36 times. Not a number I'm used to playing with. But then what am I supposed to do? I'm supposed to go 3 times 36. So I go, oh, 3 times 36, and I get 108. So you know what? If you were looking at it going, maybe it's in quadrant 1. Well, guess what? Do you feel real confident now that it would be in quadrant 2? A 3 pi fifths angle would put you in quadrant 2. And your brain goes, oh yeah, 108 degrees. Well, that's 18 more than 90 degrees. So it's an obtuse angle. But until you're super comfortable with radian measurement, and you'll get there. Until you're super comfortable with it, one of the beauties of trigonometry is you can usually draw a picture to help you visualize things. You will understand that as you go. We draw a lot of reference pictures just to get the point across. So what if they give me something funky like, well, what if they gave me something like -3 pi and they want me to convert it? What up with that? I go, okay, yeah, I'm just still going to use the same formula. I might want to put a 1 on the bottom here and make my brain happy, but pi cancels pi, and then guess what's left over? -3 times 180. That's what's left over, and I go, oh, that's -540 degrees. Okay, so -540 degrees. Now let's think about this one, because 540 is a snowboard term. 540, and it's negative. So I'm going to go around the circle one entire revolution, 360 times. But how much rotation is left over? Well, 180 degrees of rotation is left over. How did I figure that out? Well, 540 take away 360, I got to go 180 more degrees. So this big old chunky monkey of an angle I just drew would represent a -540 degree angle. So I end up right here. I do. And there you go. You can sometimes end up in a quadrant, and you can sometimes end up between a quadrant. Now, until you're super comfortable with where radian measurement takes you, right? Until you're real comfortable with that, practice this. But there's my 2 conversion formulas. And since we are now doing trig, we are exclusively doing trigonometry right now. Here are the problems I want you to do. All right, so the first one's here, first guy's here, you're converting. And it says, convert each degree measure to radians, leave answers as multiples of pi. So that means don't use your calculator and take pi and make it 3.14 and all that stuff. No. So your answers are going to all have pi in them. And then down here it says convert each radian measure to degrees. That's what it says. So none of your answers here are going to have pi in them. So here's the answer key. You know me, I love an answer key. And if you have a copy of the trig book, and I don't know if they're going to hand out trig books all year long or what, so I am not going to take any chances with this. If you have a trig book, great. If you do not have a trig book, well, guess what? This is page 98 in the trig book. So here's the answer key. And you'll see all of these answers here, they have pi in them, except for this guy. But if it's 0, you don't need to write 0 pi. It's 0. 0 radians is okay. And then down here you'll see all these guys have degrees. Okay, so this is just a bunch of convert from one to the other stuff. All right, guys. See you on the flip side. That is our first video for the trig intro unit.